There are some parts of the world that have more than their fair share of fascinating places to explore, and Sheep Mountain Anticline is one of them. I've been on this ridge many times, and I must say I never get tired of it. Even for an experienced geologist like me, I struggle to comprehend the history and processes that created this great landscape.
What a sight to behold, and how do you explain this? I mean, it looks like a big double ridge of fins on a giant, I don't know, a dragon or something. It's spectacular. And you just have to wonder, how did these form? Why are they here? And sometimes when you get into something like this, it can be a bit overwhelming. You just throw up your hands and go, I'm not sure. But if you make some simple observations, usually in geology, they're fairly basic, and you keep building on these observations, eventually you'll locate and come right in on the answer. And I think that'll happen for us as we explore the area and think about these fins and how they formed. Now, one of the first things, of course, we want to do is just look at the rock here. Now, this thin stuff, thin plated stuff, is a fine-grained limestone. And there's a fair bit of it here, a little ridge of it here, and over on the top of that hill. And underneath that hill over there, that cap, it's all gypsum. And likewise, as I hiked up here, there's some gypsum right over here on this side. And gypsum out in the desert doesn't erode very easily, and it's resistant to erosion. So it seems as though we have resistant layers, resistant to erosion, that are forming the main ridges. Okay. Well, we need to move on and make these observations and figure it out.
Clues to Earth's processes can be all around us if we are observant. With time spent outdoors, we begin to get a sense of the rhythms of nature. What rhythms do you see here just a few miles from our intriguing fins? I see two levels of rhythmic patterns. The first one is the relatively equal spacing of the lower drainages I'm walking along. Then there is the surprisingly uniform spacing of the upper drainages that feed into the lower ones. Going to Yemen, we see incredibly intricate erosional patterns, which is often the case. Yet within this region, areas of rhythm can be found. The spacing of these erosional canyons all along this long ridge is a case in point. The eastern side of the beautiful Sangre de Cristo Mountains displays this rhythm at a very large scale. I've highlighted just a few of the great valleys along this mountain range. Notice how they continue to the right side of the image. It's interesting that the spacing of these valleys is so consistent. So we observe that regularly spaced canyons and ridges are not too uncommon. I think this helps us begin to understand the fins, but clearly there is more to the story. Let's go to the flank of the Bighorn Mountains and look at another example of similar erosional features. Right off, we see giant finger-shaped slabs of limestone laying on the side of the mountain. We'll continue onward along a difficult jeep trail to another area. It's difficult to communicate the scale of this great notch cut into the mountain, but seeing my Jeep helps. How many fins do you notice? We have 3 well-developed ones over here, and 3 more that are not so well developed over here. There are many other subtly developed fins scattered about, but the one that really grabs me is the gigantic one right in the middle. Back to Sheep Mountain on perhaps my favorite hike.
I enjoyed that hike, coming around the nose of this anticline and this bent rock that's dipping steeply. I hope you've noticed this rock is dipping at about 50 degrees. That's one thing to notice. What else? Well, I'm standing in a wash, a drainage, and we have these smaller fins. And I think this is a great place to come to think about how they form and why they're here. One of the first things we need to do is look at the layers of rock and their basic properties. As I mentioned, they're steeply dipping. That could be important, I think. On top of this obvious resistant layer, which happens to be a fine-grained limestone. It's a platy, fine-grained limestone. On top of it is softer material. Especially just right over here, we have red silt and mudstone. So we have this resistant, limey layer. This is less resistant, so it's eroding a little more easily. But it's still pretty, it's a platy limestone. It just has a little more mud and silt in it. And it makes it so it erodes just a little easier for this to stand out in relief. I think that's important, as you might guess. Now, so we come here and what do we see? We see the pattern repeat itself. We have, it is a limestone, fine-grained limestone, and it's quite resistant. Holding up the ridge is what we say. It's forming this ridge. And then underneath it is very soft material there. So it stands out in relief. And it's these combination of layers of soft, hard, softer, harder, etc., steeply dipping that seems to help us form these fins. Well, the drone footage combined with the discussion we had on the outcrop, all that together, we are thinking about things and we're making these observations. And now I have a question for you. How many fins do you see here behind me and what do you think about them? Well, you might get into a lot of detail. I'll keep it simple. I see 3 basic ones here right by me. 1, 2, 3. And then further back and higher up is that big guy there, and it makes a very obvious fin. These 3 here are pretty subtle, and you might not even call them fins, but you can see how they're trying to develop, can't you? The big guy on the back, well, it's well developed. And now, with the information we have on the outcrop, we can understand why. The contrast in erosion on these front ones, where the softer material isn't so soft, it keeps it from developing really well. Whereas the big guy, if you look at the big picture, we have this soft, silty red material in front of me, and then behind it's very soft, and you have that big, thick, resistive bed. So at the larger scale, you make a big fin. Pretty neat to think about.
What a wonderful place to observe relatively small fins. How many levels of fins do you think there are here? Don't miss the ones on the back big ridge.
So what about the shape of these fins? How do they actually form? Now, first of all, I want to introduce the proper term, at least the geologists use, and they call them flatirons. So flatirons is what we have. Now, as far as the shape, I'm standing in a mini canyon. You can think of it, well, it really is a mini canyon. Obviously, it's narrow right here where the drainage is, where my foot is. And as the canyon cuts deeper and deeper, it widens more and more. And it's bringing down material, eroding material, and carrying it on out, making this V-shape cut here. Which means the next drainage over is doing the same thing, and they meet in the middle. The erosion of the drainage to form these points, these flatirons. Really neat.
Looking from above, we see all the elements. In front, we have a very soft red siltstone and shale. Then we have a layer of limestone that's quite resistant to erosion. Then behind it, a somewhat less resistant layer of red limestone and siltstone. Then a more resistant limestone, and then again some softer red material. Finally, we have all the V-shaped notches cut by erosion.
Okay, a clay model to help us out. Several layers of clay, representing rock layers, of course. We tip them up during the process of folding, tip them on edge. Now erosion's occurring through this process through time. Cuts out notches into these layers. And there you have the mini canyon that I talked about. And you can see the layers, the V shape they make. So this blue layer, if I come into here, it forms a V shape when you look at it like this. And of course here, I don't have anything soft that's eroding, so I don't form a true flatiron. But if, for instance, you can imagine if I took this light blue layer and made it soft, well, it could form a flatiron in this purple color. And so there we go. Hopefully that clay model helps out.
Now when we discover an intriguing outcrop like this one, we understand the basic elements that were involved in its creation. In this case, the light-colored rock is altered volcanic ash called bentonite and is resistant to erosion. These rocks were featured in one of my early videos. Spend a minute with me enjoying the beauty of our world while pondering the processes and time involved in creating these marvelous landscapes.
I hope you've enjoyed learning about flatirons and their formation. It's sure been fun exploring this area and learning about them and figuring out how they form. It's just wonderful to be out here on this spring day and enjoy some quiet and look at some geology, and I hope you've enjoyed it coming along with me. Thank you for watching.